So we've covered looking at the basics involved in binomial expansions using the binomial theorem when you've got a set of brackets that is written in the format of x plus y to the power of n. Now we need to up our game with this a little bit and look at slightly more complex examples. Now these can include two things. First being a bracket that has a trinomial in it rather than just an x plus y set of equations, and another one which involves multiplying together two different brackets and expanding them out as an entire expression. So we can use the binomial theorem in both of these cases to make our life a little bit easier and take away a little level of complexity when it comes to looking at expanding this all out. Now with this sort of thing, the actual best way to do it and to think about it is to look at examples. So I'm going to show you an example of each and we'll see how we get on from there. So the first example is that I want to look at expanding the bracket 2 plus the x plus x squared all to the power of 3. Now, we know how to expand brackets that are written in the format of x plus y to the power of n. Now, n doesn't change. N is still the power, so in this case, n is still 3. I still need to have the brackets written in this format, x plus y. So I need to take this set of brackets up here and write it like that. And in order to do that, what I'm going to do is take the 2 plus 3x and bracket it off and make it the x part of what would be this x plus y bracket, which would then mean that my y part would be given by the x squared. Now doing this allows me to expand the harder bracket in the format we want. I would just have a little bit more work to do. Now one thing I'm going to give you a piece of advice. I would always tend to stick with it this way, keep the x squared on its own. However, if there are subtracts anywhere in the bracket, take them into account, because remember the extra thing that brings in. We have to start looking at adding negatives and taking the negatives into expansion. So look at where any negatives are positioned with this. So in order to do this, I now know what my n is, I now know what the x is this part of the expansion, and I now know what the y is, it's the x squared. So I can start to expand it the same format. So my first term is still going to be given by the 3, 0 for the coefficient. I'm then going to have the x, which in this case is 2 plus 3x to the power of 3. So I'm going to have to expand this to the power of 3. But this is a bracket with two terms rather than a bracket with a quadratic in it of 3 terms. This is a heck of a lot easier to expand than this bracket up here. So we've removed that level of complexity when it comes to that. We then do our next term, which is going to be given by the 3, 1. And then I'm going to take this power down. So I'm going to have 2 plus 3x, this time squared. And I'm then going to multiply this by my y term, which is just the x squared. I'm then going to move on to the next term, which is given by the 3, 2 for the coefficient. I've then got to reduce the power again, so I get 2 plus the x in the bracket. I'm then going to multiply it by the x squared raised to an extra power, which is squared. I'm then going to add on my final term, again coefficient given by the 3, 3. This time, all I'm left with is what would be my y, so that's the x squared, this time to the power of n, which is cubed. Now if I expand any brackets and sort any powers and coefficients involved in each of these, what I'm then able to do is take this and actually write it out slightly simpler. So this first term here, we know that the 3, 0, this is going to give me 1. If I look at the 3, 1, what I know is that that's going to give me 3. My 3, 2, I know that that's going to give me 3. And my 3, 3, I know that's going to give me 1. So I know my coefficients that are going to go into place. If I take 2 plus 3x, I can either expand it old school, so expand it using the brackets as I normally would, or I can use another binomial expansion on this with x plus y to the power of n, where my x is 2 and my y is the 3x, and it's to the power of 3. Either way, whichever method I choose, expanding this bracket, that'll give me 8 plus 36x plus 54 x squared plus 27x cubed for my first bracket. So that's this term here. I've then got to add on the expansion of this second term. So I've got 2 plus the x squared in the bracket there, and I'm then going to multiply that by the x squared. Doing this gives me plus 12 x squared plus 36x cubed plus 27 x to the power of 4. Then do the same for this next one. So I know my coefficient is 3. I've then got x squared squared. Well, that's going to be x to the power of 4. And I'm then going to multiply this whole bracket out here by it. So I then get plus 6x to the power of 4 plus 9x to the power of 5. And then all I've got left here at the end is my x squared cubed, which is then a plus x to the power of 6. Now that I've got all of that, I just have to simplify my terms. Well, single coefficient at the end is just 8. I've only got one term that involves just an x on its own. So I've then got plus 36x. I then look for all my squared terms. So I've got 54x squared plus 12x squared. So that then gives me plus 66x squared. So I can cancel them out. Then I look for my x cubes. So I've got 27 of the x cubes. And I've then got plus 36 of the x cubes. So that then gives me plus 63 x cubed there. I've then got my x to the 4 terms, which is just these two terms here. So that's then plus 33x to the power of 4. I've then got my x to the 5, which is just plus 9x to the power of 5. Then plus my x to the power of 6. So we've taken a bracket that's like this to the power of 3 and expanded it in 3 lines. Now, if you didn't know the binomial expansion and you were just going for this hell for leather, expanding it out bracket by bracket, I can guarantee you that would have taken probably a full A4 page. It's a lot of work to do in one go. So this expansion and this technique, working on harder brackets, makes it a hell of a lot easier, and it actually simplifies our life down. Now this can actually be applied when we've got two brackets multiplied together. So for example, if I've got x plus 1 squared times x plus 2x plus x squared cubed, what I'm able to do is expand both brackets, then look at multiplying them together. So if I've got x plus 1 squared, well, you can use the binomial expansion for that if you want, but x plus 1 squared is quite straightforward to do. It's x squared plus 2x plus 1. I've then got 1 plus 2x plus x squared to the power of 3. And again, for this one, I'm going to separate it off. I'm going to make that my x, and I'm going to make the x squared my y. So what that then gives me for that second bracket is I get 30 times the 1 plus 2x cubed plus 31 times the 1 plus 2x squared. Then multiply that by the x squared itself. I then get plus 32 times the 1 plus 2x times the x squared squared, so that's then x to the power of 4. I then get plus 33 times x to the power of 2 cubed, so then times x to the power of 6. What that then means is if I then go along term by term, the first term, that becomes 1 plus 6x plus 12x squared plus 8x cubed. I then add on my second term, which is given by 3 times 1 plus 4x plus 4x squared, all times the x squared. I've then got my third term, which is given by 3x to the power of 4 times 1 plus 2x. And I've then got my final term, which is just plus the x to the 6. Multiply out these two brackets here. What I end up getting for this middle bracket here is I get 3x squared plus 12x cubed plus 12x to the power of 4. And then this bracket here gives me a plus 3x to the power of 4 plus 6x to the power of 5. What I can now do is then gather all the terms here for this one together and then see how I get on from that. So if I do that and gather everything together, I get 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the power of 4 plus 6x to the power of 5, then plus my x to the power of 6. So now that I've expanded this second bracket, what I have to remember at this stage is I'm going to take that whole bracket and multiply it by the expanded version of this first bracket. So multiply the whole thing by x squared plus 2x plus 1. Now, that seems like a heck of a job, but what I'm going to do is I'm going to lay it out in a tabular format so that I can then use columns in order to be able to simplify it a lot easier. So what do I mean when I say that? Well, I'm going to split the simpler bracket, the x plus 1 squared, into 3 separate parts. What I'm going to do is I'm going to take the whole of the second bracket and multiply it by the x squared part. I'm then going to take the whole of the second bracket again, multiply it by the 2x part, and then I'm going to take the whole of the second bracket and multiply it by 1. What I'm then going to do is add up all of these terms. Now, when I'm multiplying each of these through, what I'm going to do is I'm going to line up terms dependent on their power. So for example, if I take multiplying it by 1, let's start at the easiest part. If I multiply that whole bracket by 1, I get 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the power of 4 plus 6x to the power of 5 plus x to the power of 6. Yeah, so I've lined it up going that way by powers. If I multiply the whole thing by the 2x, what happens is I'm no longer left with a constant at the end. So when I multiply it by 2x, my lowest term, my lowest powered term, is 2x. So what I'm going to do is I'm going to line that up in a column with my x's, because what I can then do is go down each of these columns, add them together, and then my term in my final answer will be the sum within the column. So multiplying the whole thing through by 2x, I get 2x plus 12x squared plus 30x to the power of 3 plus 40x to the power of 4 plus 30x to the power of 5 plus 12x to the power of 6 plus 2x to the power of 7. What I'm then going to do is multiply the whole thing by x squared. Now when I do that, my lowest power is x squared this time. So I'm going to end up with an x squared plus 6x cubed plus 15x to the power of 4 plus 20x to the power of 5 plus 15x to the power of 6 plus 6x to the power of 7 plus x to the power of 8. So what I've done is I've now got all my powers lined up with each other. So all I have to do is go down each of these columns, total it up, and I've got my final answer. So what I've then got is I've got 1, I've then got 2x plus 6x, so I've then got plus 8x, I've then got x squared plus 12x squared plus 15, so 15 plus 12 plus 1 gives me 28, so that's then plus 28x squared. I've then got 20 plus 30 plus 6, so I've then got plus 56x to the power of 3. I've then got 15 plus 15 plus 40. I've then got plus 70x to the power of 4. I've then got 20, 30 and 6, so I've got plus 56x to the power of 5. I've then got x to the 6, 12 and then 15, so I've got plus 28x to the 6. I've got 6x7 plus 2x to the 7, so I've then got plus 8x to the power of 7, then plus x to the power of 8. Using this tabular method has helped me do it. One key thing, watch the signs. I've no negatives here, but if you get negatives, take them into account. It's just making expanding it a heck of a lot easier.